Okay, here's what we mean by using logarithmic differentiation. The idea is to use logarithmic differentiation when you have a complicated looking function that involves powers, products, and quotients. Then you can use the properties of logarithms to simplify the differentiation. Instead of, hopefully I've interpreted this correctly, that this is e to the x cubed rather than e times x cubed. So that's an assumption I'm making there. But so here I rewrite that as y equals that expression. Take the natural log of both sides, and here's where the properties of logarithms come into play. Here I've got the log. Picture the log of this product is the sum of the logs. So I've got the log of e to the x cubed plus the log of the sine of x, and then also minus the log of the denominator because that's a quotient. Properties of logarithms. Also, I can bring this x cubed down front. That's the power property of logarithms, which I've done on the next step. And by the way, the ln of e is just the number 1. Now I'm ready to take the derivative of y with respect to x. So the derivative of ln of y is 1 over y times the derivative of the inside, which would just be y prime. That's what we want to solve for. The derivative of x cubed is 3x squared. The derivative of ln of sine of x is 1 over the sine of x times the derivative of the inside, which would be cosine of x, minus the derivative of this is 1 over tangent of x minus 1 times the derivative of the inside, which would be secant squared. So y prime equals, well, I multiplied both sides of this previous equation by y. I can replace y with how it's defined, or you could just leave a y there if you wanted to, or f of x. And I did some trigonometric simplification here. Cosine over sine is cotangent. If I wanted to, I could convert this expression to all sines and cosines and simplify it, which you'll see in a second is what I did on Desmos. Okay, so there's your answer right there, or one form of the answer. On Desmos, there's your original function right there. You can use the Desmos derivative operator to graph the derivative. And if you want to, then you can type the derivative of the answer that you ended up with, and those graphs should be the same. I made the red graph a little thicker than the green graph, just for emphasis. But you can see how I rewrote this term right here in terms of sine and cos. Well, I could have cosine in the denominator times the quantity sine x minus cosine x. Okay, now if I want to, just to prove that this worked, I could have a point that's on the curve, and I can write the equation of the tangent line right here using point slope. G sub 1 of x sub 1 is the slope of the tangent line at any point x sub 1. And there's x minus x sub 1, and I move the minus f of x sub 1 to the right. There's the tangent line. And as I move that point x sub 1 along the graph of f of x, you can see that I do have tangent lines at various points. I could focus in on maybe a particular section of the graph, like right here. But it looks like we definitely have the derivative of the original function right there. Okay, there you go. Hope that helped. If you have any questions, post a comment.